Okay, so we're going to calculate empirical formula. I'm just going to guide you through this question. The question says, a compound was gravimetrically analysed and the percentage by weight of each element was determined. So percentage weight on weight of iron is equal to 70%, percentage weight on weight of oxygen is equal to 30%. Now sometimes questions will actually give you the exact weights and then you would convert it into percentage if needed. But in this case, we've just got the percentage already. And we're expected to determine the empirical formula of the compound. So to start off with, we really need to find out what the number of moles of these things is. So we're going to say, let's use 100 grams of the compound. Yep. And so we've got to turn that into grams. So we've got mass of iron is equal to 70.0 grams and mass of oxygen, I'm just going to write oxygen because O looks like a 0, is equal to 30.0 grams. Now in order for us to figure out the ratio of iron to oxygen atoms in this compound, we can't speak in maths, we have to convert to moles. So we're going to convert these to moles and we use N is equal to M over MM. That's our generic equation that we're going to be using, okay? So the moles of iron is equal to 70.0 grams over the molecular mass of iron, which is 55.85 grams per mole. And that works out to be 1.253 moles of iron. And then if we look at oxygen, moles of oxygen, and we're talking about oxygen atoms, we're not talking about oxygen molecules, is 30.0 grams over 16.00 grams per mole. And that works out to be 1.875 moles of oxygen. Okay, so we're talking about oxygen and we're talking about iron. Okay, so we've got the moles. In order to get the empirical formula, you've got to get the ratio of those things. So if we say ratio of iron to oxygen in this iron oxide compound, and remember we have no idea of what this formula will be, and it could in fact be two different formulas because iron can have different valencies. We're going to put these numbers together and we've got to work out the ratio of that in whole numbers. So I'm going to take the bigger number, 1.875, and divide it by the smaller number and try and get a ratio that is to 1. Okay, so 1.875 divided by 1.253 equals 1.4964. Okay, so that is equal to, it's equivalent to a ratio of 1 iron to 1.4964 oxygen. Now we can't have a 0.4964 of an oxygen. We're going to take that to the nearest whole number, or we're going to round that off, and we can clearly see that's about 1 to 1.5. Now you cannot have iron 1.5 oxygen. You can't have that. So we're going to have to multiply by 2, and that's going to be 2 to 3. And so our empirical formula is iron 2O3, Fe2O3. And there is our answer.